So our first sub-team is PR. One of the biggest projects we're working on this school year is the Humans of Cupertino interviews, which we've been conducting yearly. So far, we've conducted 3 Humans of Cupertino interviews, 2 of which are featured on the slideshow. And another project was a set of educational videos that we put on YouTube, which are featured up there as well. We did one on state machines, like the gyro, as well as the presentation on the Zippy workshop for FTC teams. And we also created a CNC video for Tormac, because this year we were very lucky to have received a CNC machine with thanks to the donations or sponsorships we've gotten from several organizations.
So I just wanted to add on, our CNC video has been pretty popular on YouTube so far, so we're very happy about that. Tormac also acknowledged our video because it's kind of well produced. Yeah. And then we've been doing Instagram posts and stories for our competitions and other outreach events, which you can go to our Instagram page and see. And we're also working on a music video and impact video. The impact video should be posted soon. This year, I think PR has been extraordinary in terms of how many people have signed up for our sub-team for the club. People in the team, like the robotics teams, as well as people outside of the teams. And also the coverage of photos and videos have been very well produced this year. So that really just drives our marketability as a organization. And yeah, so we're very happy with PR this year.
Is also sharing what we built with the community, because it's really fun to kind of introduce people to some of the fun stuff that we've been working on, and we're able to do this with our outreach events. Some of the outreach that we've done this year is the Silicon Valley Fun Fest. We did a senior event for card making, and this is the 3rd year that we're doing that. This was a partnership with Team Lunesta. We did an elementary school skit, which was also a lot of fun. And this year we actually made it minion themed, so it was super fun for our members to kind of get to come up with a plot and also just dress up as minions, and the students also really enjoyed it. We did an e-waste drive as well, which was something that our FTC members took part in lead on and did a great job of executing successfully, and that's something that we also want to do for the event. And then we also had this in-house supported the Shelter Robotics workshop, and this was something new that we started this year, and the goal was just kind of to introduce younger students to robotics and give them a chance to go around our club, because that's something that's key for the community to be able to. Yeah, and we just have more pictures from the e-waste drive, and then also we had a college robotics panel this year where we were able to kind of introduce our members to how to continue doing robotics in college with presentations where we use robotics and then also learn the next robotics.
Another one of our outreach events is Project Artemis, which is a workshop that aims to bridge the gender gap in STEM by introducing female and non-binary identifying middle school students to robotics. We host workshops in the fall and spring, mentored by many of the female members you see right now. Our spring workshop is starting tomorrow, and students will get to construct and code their own mini robot, which they get to take home. This project has a tremendous impact on Cupertino Robotics, and if your child is interested in our next workshop, make sure to look forward to it, which is this fall.
Okay, and the final sub-team that we'll be going over is sponsorship. Unfortunately, our sponsorship week is in Greece right now, but we're having a lot more fun than he is. But he's here in spirit. Okay, so sponsorship that help fund different aspects of our club, but also an integral part of it is getting companies to help fund our organization as well. Specifically for this season this year, some of the grants that we were able to fortunately acquire included the PG&E Dream Maker Grant and the Intuitive Foundation Grant. And then in terms of companies, one company that sponsored us was Johnson & Johnson. And then we also continued with some sponsorships that we've been working with over the past 9 years, like Lockheed Martin and Apple. On another note, one thing that we would like to mention is if you are interested, your company and a lot of parents and families from this area are from tech companies. So a lot of those companies tend to take interest in funding teams like us. So if you are interested in donating or funding or providing funding for our teams, we would really appreciate it. If you could, another thing, a way to do that is if you go to our Cupertino Robotics website, that includes a section that has our sponsorship package and our annual report, which we update every year. Our annual report includes information about why we need funding, about our teams, like you get to know our teams, and it's something that's very easy that you can send to your companies as well to let them know about why we would like to be funded by them. So again, if you are interested in this, we would really, really appreciate it, and it's obviously what keeps our team running every single year. Thank you. Okay, next up, we're going to move on to our actual teams. So starting off with our uppermost division, which is FRC First Robotics Competition, and this includes our juniors and seniors who will be presenting on behalf of their sub-teams.
Yeah, so first we'll talk a little bit about this year's game, Crescendo. It's a game that's musically based, as there are game elements and scoring objects that are used to mimic music. The main scoring element is an orange ring or hoop, which we refer to as the notes, and we can score them in 3 main systems: the speaker, amp, and trap. Our robot can also earn additional points by hanging on the chain, which is in the stage at center field. And finally, there's the human player note toss, where one of the human players, it could be someone from our team or someone from our alliance, can throw the note like a frisbee onto a pole, which when a robot is hanging on that designated location, we can earn extra points. And
this is the game for this year.
Welcome to the 2024 First Robotics Competition Game, Crescendo, presented by Haas. 2 alliances of 3 teams each compete to score or play notes in 3 different field elements. Amplify their speaker, get on stage, harmonize, and take the spotlight before time runs out. Alliances earn additional rewards for meeting specific scoring thresholds and for cooperating with their opponents. Robots start each match inside their alliance's starting zone and may be preloaded with a note. During the first 15 seconds of the match, robots are autonomous and can be programmed to leave their starting zone, play preloaded notes in their speaker or amp, and collect and play additional notes. During the following 2 minutes and 15 seconds, drivers control their robots. Robots collect notes from human players at their source and play them in their amp and speaker. Each time an alliance plays 2 notes in their amp, the human player can hit a button to amplify their speaker for 10 seconds. Notes played in an amplified speaker are worth more points than those scored in an unamplified speaker. A human player may choose to play a note scored in their amp to cooperate with their opponent. If each alliance plays a note by hitting the cooperation button in the first 45 seconds of teleop, all teams in the match receive a cooperation point, which will influence the team's rank in the tournament. The number of played notes needed for a bonus ranking point is also reduced. Robots are protected from contact by their opponents when at their podium, off the ground, and during the last 20 seconds of the match while in contact with their stage. As time runs out, robots race to get on stage and deliver notes through the flap and into the trap. Bonus points are awarded for harmony when robots on stage use the same chain. On-stage robots earn even more points if a human player spotlights the robots on a chain by scoring a note on the chain's corresponding microphone. The alliance that earns the most points wins the match.
Okay, so basically, our plan this season was to create two different mechanism designs, one for SVR and MVR, which were our two competitions. SVR was a week 1 competition, meaning that we only had 7 weeks to build the robot, and for MVR it was week 5, so we had a lot more time. So we decided to make a simpler design for SVR robots so that we would be more successful. So we decided to go for a speaker and a chain with source pickup. And for MVR, we decided to be more ambitious and go with a speaker and chain with ground and source pickup. And this is our MVR robot, and right over there is our SVR robot. And this is the CAD of our robot. All the hardware sub-teams worked tremendously hard on this, and because of the design and the planning, we were able to make this happen.
So now we can move on to the chassis, which is the base of the robot. So this is the first season we've implemented what's called a swerve chassis. So to a lot of you that might be like a new term. So for some background, the swerve chassis allows the robot to move in all directions while rotating simultaneously. Pretty cool. So we implemented swerve for both our chess chassis, which we use during Cal Games, and the season's chassis. And it's been really successful. It's allowed us to decrease our cycle time significantly, going between the source and the amp or speaker. So I'd also like to say a special thanks to Ishan. I don't think he's here. But his work allowed us to transition between the Western drive and chassis drive as smoothly as possible. All right? We can move on to the SVR mech.
Alright, so like Kyle said, SVR is a very early contest. So going to this contest, our philosophy was to keep it as simple as possible. So to that end, we basically copied the Kitbot design, which, as you can see here, only does source pickup and the source and speaker. The major upgrade we did do was to widen the intake in the funnel. That way we have a greater tolerance when we're picking up from the source. And overall, the strategy really paid off. We placed, I think, 7 of 42 at SVR, and yeah, it was a pretty good result compared to our competition, which used a more complex robot that didn't really work as consistently.
I did really want to touch on the software quickly. As Sean mentioned, the design was meant to be simple, so the software was pretty limited. When intaking, there was a limit switch that would indicate when the note was cached to the shooter, and when outtaking, we would stagger the motor power applied so that it would ensure that it was being run at the speeds that we wanted it to, and that it could reliably make it into the speaker.
This is our MVR mech. So as Shine said, it's a little more complex. We placed around 18th at the competition overall. This was a week 5 competition, so we had around 4 more weeks to build our robot. This was a totally different design philosophy than the first robot. We do have both mechs upstairs, with this one mounted on our current chassis. This robot utilized a ground intake, so it could pick up notes from the ground, and then it would transfer it to the shooter mechanism, and then that would shoot it into our speaker. This was also inspired from another design called Robot in 3 Days, which, like the name suggests, a robot in 3 days. And all we did was we basically changed the geometries so that it could mount onto our chassis, which was totally different from the robot in 3 days, as well as we improved the rigidity and efficiency of the overall mechanism. So in a video later, you'll see that this robot can do 4 notes during the autonomous period, and it can also do a faster cycle time in the 2 speaker than SBR mech. And this mechanism has been one of the most successful inter-team designs of such complexity. Usually we have trouble figuring out how to build such a complex mech and put it on before the competition that really works.
And also for the software, there are some major advancements that we made, specifically the use of PID to determine where the pivoting intake should go between ground and, I guess, transfer to shooter. And also the use of sensors on the intake to determine when a node was cached in the intake was an upgrade, definitely. Also, it was generally more robust, and automated state transitions made it much easier for drivers to control, and ultimately I think it reflected in our performance on our last day at MBR.
So the final mechanism that we have is the chain mech. So as Isaiah mentioned before, the chain mech was to climb on the chain. And for SBR and MBR, we had 2 different designs. So for SBR, it's the one on the top, and MBR is the one on the bottom. And basically what we did was we used the ratchet system with chains and sprockets to lift the robot up using hooks. And for the SBR mech, we decided to use limit switch, and for MBR, we use encoder counts to see where the hook was in relative to the robot. And this turned out to be very reliable. At SBR, we didn't not climb the chain one. We did not. I think you guys get what I'm saying. But for MBR, we didn't have as much time to test it out, but every time that we did, it did work.
Yeah, so for electrical this year, a lot of us approached electrical, essentially we were learning, right? So a lot of us didn't have too much information going into off-season and this season, but with the help of our mentors and also just a general like trial and error kind of approach, we were able to get a pretty stable electrical board and cam chain. So as you can see over there on top, that's our electrical board CAD. So our electrical leads, Sammy and Sam, worked really hard to design that. And also this year, we made some general quality of life changes for electrical. So we made 3D printed SparkMax holders, which essentially allowed us to mount our SparkMaxes onto our robot a lot easier. And with that, we actually had quite a bit of teams approach us during competition and ask us about it, and asked us to share our CAD, so that was pretty cool. We also added LEDs onto our robot, which we've been trying to do for many years. And adding LEDs, it was really cool for seeing our drivers actually use the LEDs and see them while driving to help identify our robot. So overall, electrical was pretty successful.
Pretty good.
Oh, can you repeat that?
What is a SparkMax?
Okay, so a SparkMax is essentially something that controls. Essentially, it's something that controls the motor, right? So it controls inputs the direction and also power into the motor. So for SparkMaxes, it's essentially the main thing that we use to control our robot.
For the next sub-team, automation or computer vision, every year we're responsible for any vision-aided robot alignment in the Python code. So this year the focuses were node detection and ankle tag detection to align the robot to gain elements on the field. We created a whole new Raspberry Pi system starting from May of last year, and that allowed us to enable our custom Python code. Additionally, we implemented new cameras, switching from the Logitech webcams to these wider angle audio cams and these new mounts. As Electrical mentioned before, we were able to get LEDs on the robot for the first time, and Automation wrote the LED API for that. Although we weren't able to get CV at its full potential at a competition, we were able to create a solid foundation for automation processes for the future. This is a short video about our ring alignment.
Yeah, and now we want to move on to software drive. That team is basically responsible for the robot movement on the field, both teleop and autonomous. And for this season, our focus was basically to implement state machine-driven autonomous drive code, which means that we basically define a set of states representing each individual movements within our robot's path during autonomous. And we tell the robot to essentially wait until its state is complete and then proceed to the next one. And then this year we also used odometry along with the swerve modules so that the robot would know where it is on the field during the autonomous period. And we also used this software called Shuffleboard interactively to provide more flexibility for the drivers in terms of choosing autonomous paths. And we're going to see an example of that in the videos. The first one is us testing in the RoboShack. The second one is at our second comp. For the first one, you're going to see that the robot is going to score the preloaded note and pick up the 3 close notes. And then for the second one, you're going to see that we score only 2 of the close notes, and then we're going to yield to the robot that tries to score in the amp. So, yes.
Team, the FRC team, we have like a little competition update. So we participated in 2 competitions, hopefully we know that. SBR and MBR. At SBR we ranked 7 out of 42 teams, and we were the 4th Alliance captain. This competition showed our best form since 2017 for us as a team, and our robot was consistent over 3 days, which helped us get up to 7th place. The Monterey Bay Regionals, we placed 18th out of 36. We also made it to the playoffs as the 2nd pick for the 8th Alliance. And this closes off a double playoff season, which I think Steve, our head FRC mentor, mentioned. I don't think he's seen before for our team. So we are, as a team, really happy that we got double playoffs this season. Just to talk about MBR a little bit. Our first day was all troubleshooting, so we didn't get to run any testing, and all systems were functional on day 3, which is why we're so proud of our MBR bot as well. And here's some pictures of our
Okay, and that does conclude our FRC division, all the updates for that. And next up, we're going to move on to our FTC division, First Tech Challenge, which includes our 9 and 10 So we'll start off like we did before with their game challenge for this year.
The scoring element is a plastic hexagonal-shaped pixel, 3 inches across by 1/2 inch length. There are 64 white pixels and 10 each yellow, green, and purple pixels. Teams may construct custom game and scoring elements, including paper drums and team props. The game is played on a 12-foot square playing field with a foam tile floor and 1-foot-high walls. 2 trusses are located midfield. Between the trusses is the hinged stage door. In the back of the field are the backdrops, 1 for each alliance. Beneath the backdrops are taped off backstage areas. In the front corners are taped off wings. In each quadrant of the field are 3 separate spike marks. Just inside of the front wall are white pixel location stripes, and outside of the front wall there are 3 taped off landing zones. April tags are located in the field wall and both backdrops to aid navigation. Blue and red alliance stations are on the left and right sides of the field, and in front of those are the red and blue human player stations. Before each match, pixels are stacked next to each player station and on the inside of the front wall. 4 pixels are placed on the spike marks. However, team props may be substituted for the spike mark pixels. Teams place their robots on the field, touching the side walls. Each team may preload 1 yellow and/or 1 purple pixel onto their robot. Teams may also preload 1 drone onto their robot. The spike mark pixels and team props are then randomized. The fields and players are now ready. The match begins with a 30-second autonomous period. During this time, teams may attempt to score using pre-programmed instructions and sensor inputs. A purple pixel placed on the spike mark tape earns 10 points. However, if the spike mark tape has a team prop, placing a purple pixel will earn 20 points. Each pixel in the backstage earns 3 points. And each pixel placed on the backdrop earns 5 points. If a yellow pixel is placed on the backdrop in the location indicated by the spike mark pixel, it earns 10 bonus points, or 20 points if a team prop was used as an indicator. Robots parked in the backstage earn 5 points. Pixels scored in the autonomous period will also earn points at the end of the driver control period. Following the autonomous period is the 2-minute driver control period. During this time, human players may introduce new pixels into the wings. Each pixel that is placed backstage earns 1 point, and each pixel on the backdrop earns 3 points. Each mosaic of 3 identical or 3 different pixels earns 10 points. If an alliance can build pixels above the set lines, they earn a 10-point bonus for each line they cross. The last 30 seconds of the driver control period is the end game. Robots may continue scoring pixels, and there are also ways to earn bonus points. Robots may launch drones over the truss or stage door and into the landing zones. Depending on where they're parked, they can earn 10, 20, or 30 points. Robots parked in the backstage area earn 5 points. And a robot suspended by the rigging earns 20 points. There are many ways to score in center stage. Scoring element.
Okay, hi, I'm the team manager for FTC Team 4950. So some of like brief updates or recaps of what our team was able to accomplish this year. In terms of hardware features for our intake mechanism to pick up pixels, we had 2 linear slides and a rolling intake. And we also had a mechanism with a servo and rubber bands to shoot airplanes into the zones that were specified outside the field. In terms of our software, the biggest project that we worked on this season was the OpenCV object detection for autonomous. We also had a team prop which scored us a lot more points. We also had state machines and we coded distance methods for the drive code in autonomous, and this helped us move a lot more efficiently and faster during this time period, and we prioritized having smooth teleop drive code. At our first competition at the Melbourne qualifiers, we were 9th after the qualification round, and at Saratoga we were 16. We were also one of the recipients of the Motivate Award at the Melbourne competition. Some of our team takeaways were that communication and following a clear schedule is really crucial. We noticed a lot during the season that the team wasn't exactly on board with the same schedule, and we had different deadlines for certain projects, and this affected other parts of our team. And we also learned to focus on tasks until they were completed, so that they worked 100% and we were able to rely on them.
Alright, so for Team 7128, the hardware. We got a 2-motor arm that acts like a human arm with a fly at the end. We also have a drone launcher that is powered by the rubber bands. And yeah, now to software.
Okay, so this year for software, one thing that we hope to focus on for teleop is ease of use for the drivers. So a lot of the way the driver controls it should be simple, and a lot of the features should be automated or standardized. For example, we have very well thought out driver features, such as the driving accelerates, which we thought was very intuitive for drivers. And also we could toggle up or down the turning speed so that the driver could choose whether to turn slowly for precise movements or to turn very quickly. For autonomous, I think our best achievement was using TensorFlow for pixel detection. We could locate our key prop very effectively. However, we had a few issues some of the time going to it. And now to achievements.
Okay, for achievements, we landed 9th place at Santa Clara High School and 11th place at Bellarmine. These results may be due to the ranking competition, which mainly consisted of juniors and seniors. For things to work on, we decided to focus more on communication and foresight in order to get our ideas better along from point A to point B. We also wanted to focus more on setting realistic goals and expectations so that we don't overburden ourselves for the amount of tasks we may have later. Now, on to postseason goals.
Now, after the season, what we want to focus on is sort of the longevity of our program, which in order to achieve this, our short-term goal is to train rising sophomores who want to join next year. And we as a team have sort of taken on that responsibility. And I actually have a few here. You want to raise your hands? Okay, never mind. Let's move on to the next team.
So I'll be talking about 6038 during the FTC season. So for hardware, we created a double joint mechanism with an intake attached at the end of the arm for collecting pixels and displaying them on the backdrop. For software, we incorporate linear screen to avoid jerky motion during the autonomous and teleop periods. And additionally, we struggled a lot with coding the arm mechanism with the intake, but eventually we got it to work. At one competition, we received the 3rd place award for the Think Award, which is an award for great design project and engineering throughout the entire season. Some of our team takeaways is as well to have a strict plan from the start of the year so that we stay on track with deadlines. We struggle with that a lot throughout the year, but next year we hope to improve on that. And yeah, now to the next.
Okay, so
talking for team 7610. We're the quality, which we for some reason have each year. Anyhow, for hardware, we have the same double jointed arm with a claw at the end, as well as a drill launcher, which uses one motor and one servo, which basically means the motor spins a flywheel and the servo just ruthlessly shoves the plane into the flywheel and forces us to get out of the way. Something unique about our team is that we spent a lot of time into designing our drones, where we basically decided to embrace the spirit of the challenge, and instead of just making a dart that flew straight down, we decided to use aerodynamic concepts familiar to animals to paper airplanes to make a plane that basically stalls right over the correct landing zone.
Okay, so for software, we implemented exponential teleop for our power with a closed transit drive, and we used autonomous movement, we used the eye view and the gyro movement. That was actually one of our struggles to try to get the gyro to work since it was a new upgrade. And the gyro basically is a device that measures the angle, so that was used a lot in our movement. And we also implemented that with CV, which we used in T-file detection, which is tensor-flow object detection model to detect our custom object. So we actually 3D printed a custom spherical object, which would make it easier for it to detect from all angles. And so for some of our games, we were able to successfully detect our spherical object, which resulted in a point average of about 25 points for our autonomous.
Yeah, and the last part of our software is our arm state machine, and the diagram of that is, the whole graph paper. And the point of the state machine is to minimize the amount of thinking the drivers have to do during the game, which basically means the drivers can focus more on driving and communicating and less on which joystick makes the arm go up. And for our achievements, we were 7th place after qualifiers at Bellarmine, as well as being the 4th place the 4th alliance first pick. I don't know if that's relevant. And at Saratoga, we were 9th place after qualifiers, and didn't get there, but that's fine.
Moving on to outreach and some of our takeaways. So we tried to create more of an inclusive environment this year, especially with our software team as well. We tried to include more first years so they would have an opportunity, so they'd be more ready next year. So we had them write autonomous code as well as layout code to get them familiar. And we hosted a successful summer training program, which is we hosted last summer when the first years came in. That was also new as we integrated more interactive activities, which was kind of help the first years learn a bit more and get them involved in the team. Some of the teams here actually have more freshmen than they have sophomores, so some of the freshmen had to take on the responsibility for like the hardware team and build their chassis. Some other outreach events we hosted where our team had quite a bit of Artemis mentors as well as FLL mentors. They've been talked about before. FLL is like the junior Lego League program, and we also hosted a college robotics team with the UCSD Robotics and Northeastern, in which we had a panel come on, and our team also hosted the e-waste drive. Thank you.
Okay, that concludes our FTC updates, and finally we'll do a really quick update on FLL, which is our middle school division. Okay, so similar to FRC and FTC, FLL has their own school challenge. This year it was called Masterpiece. Basically that means fields of different challenges are focused on art, creativity, and innovation. They have 13 missions total, which are challenges that they aim to complete. Oh, okay. And there were 4 teams with around 6 to 8 students each, and generally we take our students from Penn and Lawson, and all of these teams are mentored by our own FTC and FRC members. Unfortunately, we had some logistical errors this year, so we weren't able to participate in any local competitions, but despite this, we obviously wanted our students and teams to be able to display their hard work that they worked on throughout the season. So we did have 2 scrimmages that were organized. One was actually with a local Cupertino Robotics team, which is really cool to connect with them. And overall, it was just a really successful season. And finally, we'll have a quick word from one of our mentors.
Hi everyone, I'm Steve. I'm the lead mentor for I did put a couple things on the slide. I don't really feel like reading them. You can read them if you like. I'd like to just have a couple of messages for the various groups that are here. To the mentors, the ones that have been kind of sitting on the table back there. Thank you for all they've done. I know that they don't do it for me, they do it for all of the students, but it's a huge time commitment. They take away time from their personal lives, from their jobs sometimes, from everything else. So it's really great that they can give all that time and their expertise. 3 of the 4 back there are former FRC students that were on the team when, 7, 8 years ago when I started mentoring for this team, so it's really nice to see that return. It's really thank you for driving your kids to and from, and for your financial support where possible. It's really allows us to do great things like the Swerve Drive that we were able to kick in this year. Makes us more competitive, makes our students learn more. It's really great help, so thank you. Also dealing with our sometimes changing schedules and stuff like that, it is really appreciated what they do to show up on time. So thank you for that. Seniors, I know a bunch of them are not here tonight, but I hope that we see you again. I hope today is not the last time that we see you. Thank you for all of your hard work. We're excited for all the colleges and come visit us. We are always happy to see you again. Start with your name, because I'm really bad at names, especially after you graduate. I just forget the old names, new names come in. So yes, please come back and visit us. Juniors, you've got another year with us. I hope that you keep up the enthusiasm. We started a lot of great things this year. We tried a whole bunch of new things in terms of team leadership stuff. We got a cart this year. We got really cool field elements built by some of our students, as well as help from Mr. Williams. So thank you for doing all of these really cool things. We want to continue this positive motion towards next year. I think we can do even better in the competitions. So it's really exciting to see what we can do. I do want to see us build on some of that competition spirit, some of the enthusiasm that other teams have. I just don't see us like cheering as loudly as them. I'm not sure why I have to lead some of the cheers, but that did happen. And then sophomores, you're going to be joining us soon. And you saw what we accomplished this year. I hope that you can take all your learnings from FTC and continue to build on it. We are excited to have you. We're going to kick that off really soon. So please come in. I'd like to bring a lot of positive energy when we get into the room. So please bring that with you. We're open to communication. I really want to keep things moving forward, keep growing this team, and keep building on all the positive things that we've built so far. So thank you all for being here, and I'm happy to chat with you upstairs while we're showing off the robot anything.